Welcome back, everybody. Off we go. Last topic in chapter 6, catalytic hydrogenation. It is what it says. We're going to use some kind of a catalyst to deliver hydrogen molecule to another molecule. And that means two H's get delivered to an alkene in chapter 6. What I have here is a piece of platinum metal, and I have hydrogen gas. And what happens is the platinum metal will weaken the hydrogen sigma bond. I've gone to the extreme of actually breaking it, but the truth is the hydrogen just sits on top and it has a weakened hydrogen bond with platinum hydrogen interactions underneath. And what's happening here is my pi is attacking one of the hydrogens. This platinum here will be getting electrons back. That's a reduction. And the platinum here will be losing electrons because it's giving up its bond to H here. That's an oxidation. Net result for platinum is no change. Carbons both get new hydrogens. That's reduction. Both bonds happening at the same time means syn addition. So instead of using wedges and dashes for my bonds to hydrogen, I tried to show the ring coming in and out of the page like this. The ring plane is here, and both H's got delivered from underneath. I don't know if you can see that with our bright sun, but you can see it here for sure. They're both underneath here. On a test, please don't redraw your rings like that. That's nuts. On the test, we're going to do what we did here. So our answer we'll put over here. And I don't want to draw that ring over again. So it'll be here. The pi goes away. All chapter, I hope you've been noticing when you're done, the pi bond is gone. Pi's gone. You get two new H's delivered to the same side. So we'll put those in green. So either wedge or dash. And if I asked you to designate RS, for each stereo center, could you do it? I think you could. You do remember, this is only 50% of the product. The other product, instead of having wedge here, would have dash. There's no preference of top side or bottom side when you're coming into a flat alkene. We talked about that last week. So if you're going to do R and S, you better have wedge and dash. So doing R and S, we're going to do this. Remember, dash has to be adjacent to wedge. It's never too late to know that because it never goes away. So if I got a wedge there, I can have a dash here. I can have a dash here. And doing stereo centers, there's two separate ones here. Let's do those in, I don't know, one in baby blue. A 4 for an H. 1 for a branched carbon. A 2 for a carbon that goes to another carbon. And a 3 for a carbon that has no more carbons. And when I connect 1, 2, and 3 right now, the answer is wrong. How do I know that? Well, because the number 4 group's on a wedge. That's just as good as being on a dash. 1, 2, 3 in the wrong way is R, so this one is definitely S. And the other stereo center we'll do in, why not black? We haven't used black in a long time. Why is this branched C a higher priority than this branched C? Well, the two branches here are both methyls. The two branches here, one's a methyl, that's still a tie, but this is a CH2 with another C. That's going to be the CH2 with another H. And then our 3 is an unbranched C here because it only has one more bond to C, and our 4 is our H again. Wrong answer being S. Therefore, the right answer is R. There you go. So we did that part there too. And we're going to finish with just a real, we're going to finish early today, but I'm going to do a short exercise. And on a test, you're expected to be able to even see a mechanism you've never seen before. And I want you to predict the results of each step below. Okay, so I'm going to do that, reacting with OH minus. And I'm going to show you doing, let's go here. And then over here, I'm going to have you do something like this. And I'll do something like that. So I want you to predict the results of these mechanisms. We'll have 4. And over here. We could even do labeling. Ah. I don't know how interested you are in doing that. Probably not, but we're going to do it anyway. Label E, La, BA, BB, Lubnu. Okay, we'll do that too. I like it. And give the result for that. And then on this one, what are we going to do on this one? We're going to have a big clue for 2 steps prior on this one. And what are we going to do here? I like it. I like it so much. Question on one page, answers on the next page. Okay, so on this one, it didn't say anything about lone pairs, did it? It should have. Show all lone pairs, in which case, I got to retrofit my originals. Yeah. You got them all. No, I do not. Oh boy. Previous page. not retrofitted. Next page. Okay. Oh, we have part of an answer on the previous page too. I forgot the green was already there. It's okay. I'll get over it. Lone pair is still there from before. We got a C with 2 bonds to H. And now the C has a lone pair. Such a C always is a anionic C. What else do you have? You have H attached to OH, AKA water. Retrofitting this one. And this one. And getting rid of our partial answer. Fun. Okay. This is Lubnu Habibi. Oh, I shouldn't have. When is a Lubnu also your Habibi? It's a good question. When it picks up a proton. BB, like Habibi. And Ilaba. We have an Ilaba. When is your Ila also Aba? When it's giving up a proton. And hey, all the stuff you need for the labels is originally there. These are mechanisms, right? So we have a Lubnu not doing any BB action. And we have an Ila not doing any BA action. Why? No protons moving. Results? Stick with our original colors here. Whoa. I made a new page by mistake. Original oxygen, no change. And you got a new bond. Here, some of you, this reaction looks familiar, doesn't it? New lone pair up there, O minus. There you go. And there's a Bronsted reaction if I ever saw one down here. No change there. 2 lone pairs after I used the 3rd lone pair to make a bond to H. And there you go. And that's a Lubnu, the attacker. And it's attacking a hydrogen ion, which is a Lubnu Habibi. And what we have here is an Ilaba. Why ba? Because a proton's getting attacked and moving from here to the other molecule. In our final step in what would have been an aldol condensation reaction, yes, give yourself a pat on the back if you spotted that from lab. Students who don't have me for lab have no idea what I just said, which is fine. You're not responsible for this mechanism. Just give me the results that would happen with the mechanism. There's a double bond there now. And phenyl here. And yeah, we got a whole bunch of stuff here. We got the hydroxide doing its Lubnu-ness, but you're doing Lubnu-ness on a proton, so you're also a BB. Lubnu BB. And this guy is getting attacked. Loves those electrons. Lewis acid loves electrons. Electron acceptor. And then it's also a Bronsted acid. It's giving up a proton. And that is a good conclusion for today. So look for mechanisms you've never seen before, but the mechanisms provided to you, and you just give me what would result. And that shows you understand what these curved arrows mean. And that becomes progressively more and more important as we get towards a final exam that is 50% mechanisms. And yes, I said that. So I will talk to you on Wednesday, and I Wish you all. We have a question. I'm not going to end. Hello.
Not a question. It's just the lecture on 1028 is still not posted for us to review it.
Thanks for reminding me of that. Next time that happens, send me a quick email. Maybe you probably did, didn't you? So 1028. In fact, if it doesn't get posted now, because I'm going to focus on these notes, if it doesn't get posted today, then please email me a reminder. I'm going to try to remember 1028. So all 4 segments were never posted. 1028. I will try to remember. And then with that, I wish you well, and I will see you guys Wednesday. Bye-bye. Take care.